Now let's get some practice with factoring quadratic expressions. Factoring is one of those things that the more you do it, the more comfortable you're going to get with it. So the more practice you can do, the easier it's going to seem. So remember with factoring, we're going to take something that's given to us in this form, and we want to write it into its factored form. Now if we multiply out the factored form, our coefficient for our x term, which would match up with p over here, is going to be a plus b. Our coefficient for our constant term, which would match up with q over here, would be a times b. So once we have a p and a q, we're looking for two numbers that multiply to be q and add to be p. So in this first example, our q is positive 3. So let's think of all the different combinations of two numbers we can multiply to get positive 3. Well, the easy one in any case is going to be the number times itself, so 3 times 1. But I can also take negative 3 times negative 1. That'll also give me positive 3. But we're looking for the pair that adds up to 4. So 3 plus 1, that gives me 4. Negative 3 plus negative 1 isn't going to give me positive 4. So this is the pair I want. Here's my A, here's my B, or vice versa. We can always flip them. It doesn't matter because multiplication is commutative. So we get x plus 3 times x plus 1, or x plus 1 times x plus 3. So that one wasn't too bad. 3 is prime, so we only had two possibilities for A and B. Let's look at this one now. Notice we have a subtraction sign in there, a negative, so we need to be a little bit more careful with our signs. We just have to keep close track of it. Otherwise, everything's exactly the same. So q is 4, so we need to think of all the ways we can multiply two numbers to get 4. Well, the easy one is 4 and 1, which means that negative 4 and negative 1 will also work. And then 2 times 2 is also 4. So 2 and 2 is one pair, negative 2 and negative 2 is another pair. Now we want to determine which of these pairs is going to add to negative 5. So 4 plus 1 and 2 plus 2 are both going to be positive numbers, so we know that they're definitely not going to add to negative 5. Negative 2 plus negative 2 will be negative 4, so that's not the pair we're looking for, but 4 and negative 1 adds to be negative 5. So this is the pair we want. So we can write our factored form as x plus negative 4, or just x minus 4, times x plus negative 1, or just x minus 1. Now let's look at our third example. So our q in this case is negative 7, so we got to be careful with that negative. So our options to get negative 7 when multiplying are either negative 7 times 1 or 7 times negative 1. Those are the two and only two ways we can get negative 7 by multiplying integers. So we need our pair to add to negative 6. So negative 7 plus 1 already gives us negative 6, so we know that we found the right pair. So we have x plus negative 7, or x minus 7, times x plus 1. There's our factored form. And notice we just have to be careful that we put the negative with the right number, because if I used positive 7 and negative 1, this would add to positive 6, which is not what I have here. So that just means we have to be careful. Now let's look at number 4. Q here is negative 15. So let's think about all our possibilities. We could have negative 15 and positive 1. We could have 15 and negative 1. We could have 3 and negative 5. Or we could have negative 3 and positive 5. Those would be all our possibilities to get 15. Negative 15, I should say. So we want the one that adds to 2. So negative 15 plus 1 is going to be negative 14. It's not what we're looking for. 15 plus negative 1 is going to be 14, not what we're looking for. 3 plus negative 5 will be negative 2, which is close, but still not what we want. But negative 3 plus positive 5 does give us a positive 2. So this is the pair we want. So we'll get x minus 3 times x plus 5. Now if you're getting comfortable with doing this without writing all the pairs down, and you can kind of figure it out in your head, as long as you're being careful, especially with negatives and positives and making sure you're putting them with the right numbers, you don't need to write all this out. I'm kind of going step by step by step here. Okay, let's look at this example. We have 12 as our q. And now the thing about 12 is that it has even more factors than any of the ones we've looked at so far. Because we could multiply 12 times 1, could multiply negative 12 times negative 1, could multiply 6 times 2, negative 6 times negative 2, 3 times 4, or negative 3 times negative 4. That's a lot of options. So if you're getting comfortable with this and you can see immediately which one is correct, that's fine. I'm going to go through and add them all, make sure I know which one is right. So 12 plus 1 is 13, that's no good. Negative 12 plus negative 1, negative 13, no good. 6 plus 2 is 8, not what we're looking for. Negative 6 plus negative 2, negative 8, still not what we're looking for. 3 plus 4 is 7, still not what we're looking for because we want a negative 7. But negative 3 plus negative 4 will give us negative 7. So here are our a and b. So x plus negative 3 times x plus negative 4. There is our factored form. Now notice to switch from this fifth example to the sixth example, all I did was change one sign. Instead of adding 12, I now want to subtract 12. So we have the same sets of factors, but we need to make sure that each set has one positive and one negative. So we have negative 12 and positive 1. We have positive 12, negative 1. We have negative 6, positive 2, positive 6, negative 2, negative 3, positive 4, and positive 3, negative 4. Those are all our possible factors or pairs for negative 12. Now let's add them and see if we can get one that matches with the negative 7. So negative 12 plus 1, negative 11. It's not what we want. 12 plus negative 1 gives me positive 11, still not what we're looking for. Negative 6 plus 2 gives us negative 4, it's no good. 6 plus negative 2 gives us positive 4, still no good. Negative 3 plus positive 4 gives us 1, still not what we're looking for. And 3 plus negative 4 gives us negative 1. So none of these pairs of integers will give us a negative 7 as our a plus b term. So that means that we don't actually have a way to factor this equation or this expression with integers. So most likely we'd go about it a different way. Rather than trying to factor it, we would just leave it alone and use the quadratic formula or some other type of way to solve it. Now let's look at a couple special cases of factoring. We have difference of two squares, that's one special type of factoring. And we also had special case where our factored form was a perfect square. So let's look at both of those and see if they relate or work nicely with this type of factoring. So let's take first x squared minus 6x plus 9. So it may well be that this form is the x squared plus 2ax plus a squared that we would look for in a perfect square form. But before we think about that, let's think about our pairs that we can get from 9. So we want positive 9, so we can take 9 times 1, negative 9 and negative 1, positive 3 and positive 3, or negative 3 and negative 3. Now, if we want them to add to negative 6, 9 and 1 won't work, negative 9, negative 1 won't work, positive 3 and positive 3 will give me positive 6, so my pair would be the negative 3 and negative 3 that would give me the negative 6. So our factored form is x minus 3 times x minus 3, which we notice is indeed x minus 3 squared. So if we think of this as a 2ax and an a squared, let's see if that makes sense. So if negative 6 is 2ax, a would be negative 3. If we square negative 3, we do indeed get 9. So we see that this is indeed our perfect square form. So we could have just recognized that at first and gotten this without having to go through all the pairs and figure out which one it was. But we see that we get the same answer either way. It's going to be helpful in a lot of situations. For instance, completing the square, it's really helpful to know this and not have to factor it every single time using the pairs and this type of work. The other thing we had talked about, or you may know of, is the difference of two squares. So we have two numbers that are both perfect squares and we're subtracting them. So if we think about 100, the pairs that multiply to be 100 are 100 and negative 1, because we're looking for negative 100, negative 100 and positive 1, and then there are a whole bunch more. We could take 50 and negative 2, negative 50 and positive 2. We could take 25 and 4. The other one that I can think of real quick, obviously there are going to be others, but is 10 and negative 10, or negative 10 and 10. So we'll kind of, there are more, but I'm not going to list all of them out. Now, if we think about it in this form, we don't have an x term, so that means p is 0. So we need a pair that's going to make 0 when we add it. Well, this isn't, these two aren't, 25 and 4 won't either. But look at these two. They're really the same pair because they are made up of the same numbers. So if I take 10 and I add negative 10, that is going to be 0. So that means that this is the pair we want. So we can write this as x minus 10 times x plus 10 in its factored form, which we know is already the way we would factor the difference of two squares.